Because we have in upper limit infinity, so first thing we do is convert the integral to a limit. So this is equal limit, and we will replace infinity with a variable. We will put t goes to infinity, and we have integral now from 1 to t of natural logarithm of x over x dx. So now, before we do limit, we have to find definite integral. When we do definite integral, we have to have continuous function. Let's check. We cannot have 0 in the numerator, and natural logarithm we calculate only for positive values. And we have here interval from 1 to infinity, because t goes to infinity. So 0 doesn't belong, and we have only positive values. So our function is continuous, so it means everything is correct. Now we have to find first integral of natural logarithm of x over x with respect to x. To do this, we will use integration by parts formula. So let me remind you that when we have integral, let me put this here, of f of x, g prime of x with respect to x, this is equal f of x times g of x minus integral of f prime of x, g of x dx. In this example, we will put that f of x is equal natural logarithm of x. Why? Because f prime of x will reduce our natural logarithm, and the root of natural logarithm will be 1 over x. So we don't have now natural logarithm, and we will put that g prime of x is equal 1 over x. So g of x is natural logarithm of x. So now we will come back to our integral, and we have that this is equal, we have f times g, so natural logarithm times natural logarithm, so we have natural logarithm of x square minus, and we have integral of f prime is 1 over x, and g is natural logarithm of x with respect to x. So now, because we have here the same expression like we had at the beginning, and we have negative sign, let me rewrite this whole for equation. We have integral of natural logarithm of x over x dx is equal natural logarithm of x square minus integral, and I can write that this is natural logarithm of x over x dx. We have the same expression on the right and on the left, but we have negative sign. So I will move this whole expression to left side. So we will have 2 integral of natural logarithm of x over x dx. This is equal natural logarithm of x to second power. Now, to find this integral, I will divide both sides by 2. So we have that integral of natural logarithm of x over x with respect to x is equal natural logarithm of x second power over 2. So we have our integral. So we now have to come back to our limit, and let me copy. We have limit t goes to infinity. Because we have here definite integral, so we have to copy our result. We can write that we have 1/2 natural logarithm of x to second power, and we have to put the limits of our integration. We have from 1 to t, so this is equal limit. We have to rewrite t goes to infinity, and first we will plug upper limit. So we have 1/2, and in brackets we will put natural logarithm now will be of t to second power minus we will have natural logarithm of 1 to second power. So this is equal. We have limit t goes to infinity, and in brackets we have natural logarithm of t to second power, of course 1/2 we have, minus natural logarithm of 1 is 0. 0 square is 0, we don't have to write. So now when t goes to infinity, we have natural logarithm of infinity. Let me write the graph of our natural logarithm. When t goes to infinity, our graph goes to infinity. So we have 1/2 times infinity is still will be infinity. So we have infinity. So it means that our original integral, which we have at the beginning, is divergent because we didn't get finite numbered. Let me write this. Divergent. This is my solution.